8th question of the model paper. 25 cubic centimeters of ferrous oxalate is treated with, you can draw a rough diagram. 25 cubic centimeters of ferrous oxalate is treated with 0.05 moles per cubic decimeter. That is the concentration. Potassium permanganate solution, which is acidified with diluted sulfuric acid. Volume of potassium permanganate reacted at the end point is 30 cubic centimeters. What is the concentration of ferrous ions in ferrous oxalate solution? So there is a reaction between ferrous oxalate and potassium permanganate in acidic medium. Therefore, first we need to write the balanced chemical equation for that reaction. Can you remember the half reaction of permanganate ions in acidic medium? If so, please pause the video and write that balanced equation for the half reaction. So it is 8 hydrogen ions, 1 permanganate ion, 5 electrons, 1 manganese ion, 4 water molecules. You can balance this equation using the rules, but if you remember the equation, then it is very easy to get the final answer. Then what about ferrous oxalate? Ferrous oxalate contains ferrous ions. Ferrous ions oxidize to ferric ions by permanganate ion, because permanganate is an oxidizing agent. Then oxalate ion oxidizes to carbon dioxide. So we can write oxidation half reactions for both ferrous ion and the oxalate ion. Then we can add these two equations in the 1:1 mole ratio to get the overall oxidation half reaction. Then ferrous oxalate one ferric ion, 2 carbon dioxide molecules, and 3 electrons. So this is the reduction half reaction, this is the oxidation half reaction. Check whether these two reactions are correct in your rough sheet. Now we can add these two equations. 5 electrons were gained, 3 electrons were released. So we need to multiply first equation by 3, second equation by 5. Then we can add those two resulting equations. So it will be 24 hydrogen ions, 3 permanganate ions, 15 electrons, 5 ferrous oxalates, that is the reactant side. Then we can write product side. 3 manganese ions, 12 water molecules, 5 ferric ions, 10 carbon dioxide molecules, 15 electrons. So 15 electrons, 15 electrons cancels out. So this is the ionic balanced chemical equation. Using this we can do the calculation. We know the concentration of the potassium permanganate solution and the volume of the reacted potassium permanganate solution. So we can calculate number of moles of potassium permanganate. Number of moles of potassium permanganate reacted. So how to calculate number of moles of potassium permanganate? We need this equation. Concentration is number of moles over volume. So we can multiply both sides by volume of the solution. So number of moles is concentration times the volume of the solution. Concentration of the potassium permanganate solution is 0.05 moles per cubic decimeter. Then volume is 30 cubic centimeters. That means 0.03 cubic decimeters. Cubic decimeters times per cubic decimeter. Then 5 times 3, 15. 4 decimal places. Unit moles. So there are 3 permanganate ions. That means there must be 3 potassium permanganates. We can write 3 potassium ions in the product side. Mole ratio between potassium permanganate to ferrous oxalate, it is 3 to 5. Using that relationship, we can calculate number of moles of ferrous oxalate reacted. Number of moles of ferrous oxalate reacted. 0.0015 moles. We need to divide this value by 3. Then we need to multiply by 5. So when we divide this by 3, it is 0.0005. So the answer is 5 times 5, 25, 4 decimal places. So that is the number of moles of ferrous oxalate reacted. We need to calculate concentration of ferrous ions in ferrous oxalate solution. So we know that when we consider 1 mole of ferrous oxalate, it contains 1 mole of ferrous ions and 1 mole of oxalate ions. We can use this relationship. Therefore, we can calculate number of moles of ferrous ions in the solution. So it is same as the number of moles of ferrous oxalate, which means 0.0025 moles. Now we can calculate the concentration of ferrous ions. concentration of ferrous ions. So how to calculate the concentration of ferrous ions? We know the relationship. Concentration is number of moles over volume of the solution. There were 0.0025 moles of ferrous ions. Volume was 25 cubic centimeters. That means 0.025 cubic decimeters. Do you know how to convert cubic centimeters to cubic decimeters? We need to divide by 1000. 25 divided by 1000, which means 0.025. So we can move 3 decimal places to right, then this fraction becomes 2.5 over 25. There are no 25s in 2, therefore 0, then decimal place 25, 25 divided by 25, 1 units moles per cubic decimeter. So it is 0.1 moles per cubic decimeter is the concentration of ferrous ions in the given solution. So we can deduce that the correct answer for this question is the third one. In the third answer, it is given that the concentration is 0.1 moles per cubic decimeter. Therefore, that is the correct answer. This is how you should obtain the answer to this question, as this is a reaction, as this is a calculation involving a reaction. First we need to write the balanced chemical equation. So to write the balanced chemical equation, we need to use the half reaction method, as this is an oxidation reduction reaction. After obtaining the balanced chemical equation for the reaction, we can do the calculation step by step like this. So if you feel these calculations are a bit difficult, you can refer to my 2 workbooks. They are chemical calculation workbook and oxidation and reduction workbook. You may refer to those books and get familiarized with these concepts. If you want to boost your chemistry marks, you can join our online paper discussion class. WhatsApp now to join. Don't wait. To get this question paper free of charge, WhatsApp now to 071 7191 626.